Okay, so this one is about solving equations. Everything we did up till now was all about expressions. You know, what can you do with an expression? You simplify it. You can add them, subtract them, and all that. But now we're with equations. And what do you do with equations? You solve. So solving radical equations. You know, and they give like 2 bullets here. The first one's self-explanatory, right? Solve an equation has a radical expression in it. The second one, it says verify possible solutions. In a way, that could refer to, let's say you got the question in a multiple choice format. Would you be able to go back and check to see whether the answer worked? But it also might mean just the process of checking your answer, because we do have to check our answers here sometimes. So we'll see how that goes. The basic steps for solving radical equations are these. And if they seem kind of familiar, it's because it's almost identical to what we do for absolute value. You isolate, then you undo, right? For an absolute value, that meant either breaking it into 2 different equations or inequalities or a 3-part inequality. For these, what we mean by undo the radical is, okay, well, if your radical is a square root, what do you think you'll do to undo it? Square both sides. If it's a cubed root, what will you do? Cube both sides. So it'll depend on what the radical is, what you do to undo it. Okay. Once you've undone it, there will be something left to solve. And then the checking part, just like with absolute value, sometimes we had extraneous solutions, and the same thing can happen with radical equations. Sometimes it's important to check for extraneous. I mean, it's always a good idea to check your answer. But I think it's a little bit, I don't always say it correctly, maybe. If you look at, like, the first example that we're going to do here, and there's the same here, right? If we get down to the end here and we check our answer and it's not right, it's not extraneous. You just did something wrong. Okay? Every time your answer doesn't check, doesn't necessarily mean it's extraneous. You might have just got the wrong answer. Of course it didn't check. Right? There's a particular kind of problem which has extraneous. Just like with absolute value, that was when you had an x which was inside and an x which was outside. It'll be exactly the same thing. But if you only have the x's inside, if you check and get a wrong answer, don't throw it out and say, oh, that's extraneous. No, it's a wrong answer. That's what it is. Okay, so let's try to follow the steps. What do I need to do to isolate this radical? Right? Subtract 3. So now we've got the square root of 2x minus 3 equals 5. Okay, we've isolated the radical. Now we're going to undo it. It's a square root. How will we undo the square root? Square both sides. Right? Okay, well, what do you get when you square a square root? You get what's inside, right? So the 2x minus 3 equals 25. Right? That was the step of undoing the square root. Okay, now you're left with an equation, you know, which may be any kind of equation. In this case, it's a linear equation, meaning x to the first, meaning that you'll be able to solve this using just basic algebra kind of stuff, right? So what will you do? Add 3, divide by 2. Right, so you could check 2 times 14, 28, 28 minus 3, 25. The square root of 25 is 5 plus 3 is 8, so it checks. But again, if it didn't check, it wouldn't be because it was extraneous. It's probably you did something wrong in the math. Okay, we'll do the same thing for practice. Even it's not a great example. In fact, I'll do it. It won't take us long. Add 5, All right, square both sides. And then we get 4x plus 1 equals 25. Solve. 4x equals 24. X equals 6. All right, too easy. So try that one. Try to follow the same steps for that. Who got an answer? Ashley, what'd you get? 2? 2 is correct. Okay, so we would add 2, square both sides, subtract 2. Again, too basic. We'll have some more complicated solving of equations after this. Okay, now, as we learned in the last lesson, actually radicals could be written with rational exponents. And if they are, there's a couple different ways to attack it. In the first one, well, just convert it to a radical form, right? I mean, we know how to do that, and we've already seen how we solve the equation if it's in a radical form. So if you're more comfortable with it, convert it, and then follow the same steps that we did before. So this is the new step right here. Okay, I'm going to go to the next slide. The same, it's all written up here if you were still copying anything. So again, the first step would be convert the rational form to a radical form. Now, I mean, that's not the whole equation. That's just this little piece right there. What would that look like as a radical? What would be the index? The denominator is the index. And then what goes inside? Okay. So that's just taking that one piece and writing it as a radical. And then you still have the 3 in front and the 12 here. So now we follow the same steps as we did before. I've never taught this way before. I don't know if anybody teaches this. It just occurred to me, maybe some students will find this easier. I'll show you what you will find in the book and what I've done in the past. But you may prefer this, really. Okay, now isolate the radical. Divide by 3, right? So this is divide 3, divide 3. So now we've got the third root of x plus 1 squared equals 4. Okay, have we isolated the radical? Okay, remember, don't get confused. Inside, it's squared, but the radical is a cubed root. So what are we going to do to undo the radical? Cube it, right? So, if you're doing this on your own paper, you probably just on this line itself, just go ahead and cube both sides. And I'm writing an extra line just so it would be clear, like if you were downloading the slides or something, that you would see each step in what we did. So that's the third root of x plus 1 squared to the third. And if you do it to one side, you got to do it to the other side. Oops, and I didn't do it to the other side. Right, so what do we get when we cube a cubed root? They cancel each other out. X plus 1 squared equals 4 to the third, 64. Now, we still have to solve for the x. And, I mean, you could do this, right? Well, how do you simplify x plus 1 squared? Well, I'm saying if you were just given x plus 1 and told to simplify it, what would you do? You would FOIL it. X plus 1 times x plus 1. If you did that, you would get this. I'm going this way because that's not what we're going to do. But you would get this. X squared plus 2x plus 1 equals 64. And you would say, okay, well, that's a quadratic. How do you solve quadratics? You factor, use quadratic formula, right? We have methods to do that. They all depend on having everything on one side, 0 on the other. So if I subtract the 64, I get x squared plus 2x minus 63 equals 0. And that's factorable, right? That's x plus 9 times x minus 7. Now, if in the chapter 4 on quadratics, in that section on completing the square, which we only kind of skimmed over, they wouldn't have done that. At this step right here, they would have said, well, let's just take the square root of both sides. If I want to get at the x, which is inside parentheses being squared, then let me take the square root of both sides. Again, I'm going to write it so you see it. Right? What do you get when you take the square root of a square? They cancel each other out again. So now we've got x plus 1. And what do we have on the right? 8 and negative 8. Because remember, when you take the square root in the course of solving an equation, you got to do the plus and minus. It's only if you were presented with a square root of 64, just like that, to simplify, you would assume they mean the positive. But if you're taking the square root, you got to say plus or minus 8. Now, to solve for x, I need to subtract 1. So it looks x equals negative 1 plus or minus 8. And that would give us negative 1 plus 8, 7. Negative 1 minus 8, negative 9. 2 answers, right? If I kept going up here, I would have had x plus 9 times x minus 7. And what would the 2 answers have been? Negative 9, positive 7. Right? That's why it would not have been enough. If I just had the 8 here, I would not have gotten the 2 answers. You have to do plus or minus. Okay, how about this one? Again, convert it to a radical. What's the radical going to look like? What's the index of the radical? 4, right? And what goes inside the radical? X minus 2 cubed. So that's 3 times that equals 24. Okay, isolate. The fourth root of x minus 2 to the third equals 8. Okay, now how do I undo a fourth root? Raise it to the fourth power, right? So I need to raise this to the fourth power. So that'll be x minus 2 to the third raised to the fourth equals 8 to the fourth. Again, when you take the raised to the fourth power, a fourth root, they cancel each other out. And now we've got the x minus 2 to the third equals 4096. So let me write this up here. X minus 2 cubed equals 4096. Okay, now, if I would do, which I just kind of did as a extra thing, you know, if I just, okay, let me just multiply it all out, and then I'll solve it, okay? For this one, that's not a FOIL. That's x minus 2 times x minus 2 times x minus 2. That's going to become a lot more complicated if we go that route. And then in the end, what kind of polynomial would you have to solve? A cubic. I mean, we don't want to go down that route. Instead, definitely, if you want to solve the x, which is inside parentheses being cubed, take the cube root of both sides. Take the cubed root here and the cubed root here. Again, the cubed root of a cube, we just get x minus 2. And what's the third root of 4096? 16. Okay. Okay, now does this need to be plus or minus? Just a plus. Why, Curtis? Because it's a cubed root. That's only even roots you do the plus or minus. So it's just the 16. And now one last step to solve. X equals 18. Okay, that's method 1. New and improved. Method 2. Isolate the radical. But this time the radical is the rational form, right? It's the thing that has the fraction as an exponent. Isolate that first. And then to undo it, you're going to raise to the reciprocal power. And we'll see what that means on the next slide. And then we're going to have to include absolute value symbols when necessary. And you'll see what we mean by that. So it's still, it's like it's the same, it's this basic 4 steps that we started with, but it means something just a little bit different if you're starting with a rational exponent. Okay. So again, this time we're not going to convert it. It's the same problem that we did before, right? Instead, we're going to isolate first. What should I do to isolate? Divide by 3, right? I mean, understand again, that is the radical. So we're isolating that. Now we've got x plus 1 to the 2/3 equals 4. That's the first step. Second step, we're going to raise each side to the reciprocal power of that 2/3. What's the reciprocal of 2/3? 3/2. So do this. Do to the 3/2 to the 3/2. Now, what do you get when you raise? Well, first let's do the 4. What's 4 to the 2/3? The square root of 4 cubed. The square root of 4, 2. 2 to the 3rd is 8, right? Okay, now over here, what's the operation? When you raise a power to a power, what do you do with those? You multiply, okay? Well, what's 2/3 times 3/2? 1, right? So that essentially they cancel each other out, and all you get is x plus 1. But when we did that, what kind of a radical was that? When we raised to the 3/2 power, what would have been the index of that radical? The 2. It would have been a square root, right? And what do we know? We're supposed to assume that the square root is positive. So to make sure that this x plus 1 that we just took out of a square root is positive, we have to put it in absolute value. That's what that means, right? Because this, let's read it up here again. Raised to the reciprocal power, include absolute value if the exponent has an even denominator, right? If that exponent has an even denominator, that means that one right there. And because it did, we had to use absolute value. Okay, now how do you solve absolute value equation? You make two equations. X plus 1 equals 8, and x plus 1 equals negative 8. Right? Solve. X equals 7, x equals negative 9. Which we already solved this in the other way, and those were the answers that we got. In fact, we've done it 3 ways, right? We did it in the way we foiled and got everything into one side. And we did it by the other way, and then we did it like that. So there's 3 ways. Every time we got the same thing. So it must be valid. Okay, and then again, this is the one we already did. Isolate. X minus 2 to the 3/4 equals 8. Okay, raised to the reciprocal power. Okay, what's the reciprocal? 4/3. So to raise this to the 4/3, which means you got to raise this to the 4/3. Okay, well, what is 8 to the 4/3? Right, it would be the cubed root of 3, 2, to the 4th power, 16. Okay, and then again, raising a power to a power, you multiply, but because we pick the reciprocal, that's going to be 1, and all you get is the x minus 2. Now, in this case, do we need to use absolute value? Again, remember, it's that denominator right there, right? If that was even, use absolute value, but that's not. It's odd. So no absolute value. So just solve that. X equals 18. So which way do you think is better? This way or the other way? This way? You know, to me, it doesn't matter how you do it. You know, if you have this kind of problem, if you choose to make it a radical and solve it like that, or if you choose to do this, Yeah, but you do have to keep track of that one thing right there. You do have to keep track of that. Yeah. No, doesn't matter. Okay, so try to do that one. You could choose either way you want. How do we do? Still going? Yeah. Sure. Got one right answer. Okay, how did you do it? You did that, set that denominator there as a 3. You don't need the absolute value. So you're good, you're done. So what was the answer? 8. Too easy. Oh my gosh. So here we go. X plus 1 to the 3 halves equals 27. Raise both sides to the 2/3. 2/3. Okay, 27 to the 2/3, 9. 3 halves to the 2/3 cancel. X equals 8. Right? Okay. And again, because that was a 2/3 odd denominator, you didn't need absolute value. Good. 27 to the 2/3. What's the cube root of 27? 3. 3 squared is 9. Or put it in the calculator. Okay. Now this is where we get into this. The check is important because extraneous is possible because we've got a x outside the radical. Okay. Trying to see. Okay, I see that. So we're still going to follow the same steps. Isolate the radical. What do I have to do to isolate this radical? Add 5, right? So that's x plus 7 equals, the square root of x plus 7 equals x plus 5. Okay, then undo the radical. It's the square root. Square both sides, right? The square root of x plus 7 squared equals x plus 5 squared. Okay, the square of the square root gives us x plus 7. And then how are we going to do x plus 5? It's a FOIL, right? X plus 5 times x plus 5. Remember, this is not the place where you can just distribute the exponent, not when you've got more than one term. That doesn't work. Right? You have to do x plus 5 times x plus 5. And x plus 5 times x plus 5 is x squared plus 10x plus 25. Okay, what kind of a equation is this? It's quadratic, so you got to solve it like a quadratic, right? We need everything on one side, 0 on the other. So subtract x and subtract 7 from the left. That will give us a 0 on the left. But if I do it there, I got to do it here. X squared plus 9x plus 18. So you don't know until you get to that point how you could solve. Most of these are going to be factorable. Is this factorable? What are the factors of 18 that add up to 9? 6 and 3. So we've got 0 equals x plus 3 times x plus 6. So what does x equal? Yeah, x equals -3 and -6. All right, but now we need to check, because clearly this is the kind of situation where you might get an extraneous solution. So let's go back up here, and in the place of x, right, you're going to put first a -3 and then a -6. So I'll do the -3. I'm going to do it right here. The square root of -3 plus 7 minus 5 equals -3. Right? That tells you that the square root of 4 minus 5 equals -3. 2 minus 5 equals -3. Is that okay? Sure. So that checks. Check. Okay, now try the -6. The square root of -6 plus 7 minus 5 equals -6. Okay, that'll be the square root of 1 minus 5 equals -6. Right? 1 minus 5 equals -6. Is that true? No. It's not -1, it's 1. So 1 minus 5 is -4. That is not equal. Right? That tells you that x equals 6 is extraneous. So, I mean, if you get a problem that has an x inside and an x outside, you got to check. Right? To me, if you're not checking, that's a kind of a significant thing that you're missing on. On the others, I mean, if you check, it's fine. But if your answer doesn't work, it's not because it's extraneous, it's because you got the wrong answer. Okay, let's see. We're getting there. And again, you could have it. You could have one of these extraneous situations with the rational form. Now, take your pick. I put up both sets of directions. Just which one do you want to use? Did we agree that you like that one better?
Yeah.
Okay. So let's delete this one. And I'll keep that one up. Blue. All right. So add to the other side. Ooh, let me erase that. I want to leave some space to check later on. So we're going to say 5x minus 4 to the 1/2 equals x. Okay, what am I going to do to, what power will I raise both sides to? 2 over 1, right, which is 2. So now we've got 5x minus 4 equals x squared. Do I need absolute value symbols? No, I mean, we don't need, the denominator there is 1, so we don't need it. Okay, now, quadratic, what do I need to do? Get everything on one side, 0 on the other, right? You could move the x squared over here to negative x squared, but I would prefer to have a positive leading term, x squared. So this will look like x squared minus 5x plus 4. So how does that factor? -1, -4. So x equals 1 and 4. So let's check, right? And we can do it here. 5 times 1 minus 4 to the 1/2 minus 1 equals 0. Okay, well, 5 minus 4 is 1. What's the square root of 1? 1 minus 1 is 0. Check. That's a check. Try this one. 5 times 4 minus 4 to the 1/2 minus 4 equals 0. So that'll be 20 minus 4 is 16. The square root of 16 is 4. 4 minus 4 is 0. So that checks. So no extraneous. They were both good. Okay. So let's see. I forget what I got on the next one. So again, you try the next one. Try that one. Let me put those directions back up there that you like. Oh, that's exactly the opposite, isn't it? Ah, forget it. Just do it. Oh, I know what I did wrong. Because that one's not a rational form anyway, so basically those are the directions. Oh, no, we didn't need to do that. Sorry. Let's do this. I'm all goofed up. Undo. 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 Undo one more time. There we go. No, I did. Undo. There we go. Minus 6x plus 9. Minus 11x plus 10. Okay, minus 10. I assume we all got that far, right? And did we all get this far? 5x minus 1 equals x minus 3 squared. Okay. Did we all get this far? 5x minus 1 equals x squared minus 6x plus 9? No. No. Then get there, right? FOIL. X minus 3 times x minus 3. Why don't you actually put it on paper and see what it looks like? No, put it on paper. X minus 3 times x minus 3 is x squared minus 3x minus 3x plus 9. You can't put it in the calculator. It's evaluating an expression. It's not. You can't put that in the calculator. You have to know how to FOIL that and get that. Try it, -3 minus 3. Try it again. It's -6. Okay. So give me a calculator. Give me a, okay, let me see.
Oh, because
You
I
had
had
a negative 3, okay?
Oh, okay.
Okay, so then what do you do from here? Subtract the 5x and add 1, so you get x squared minus 11x plus 10. So x minus 10 times x minus 1. So x equals 10 and 1. How many got those two?
Me.
Okay. What's that? Okay, what are the factors of 10 that add up to negative 11? Okay, and then you check them. Which one didn't check? Which one of these two answers was extraneous? I mean, look, if you put in the 10, 5 times 10 is 50. 50 minus 1 is 49. What's the square root of 49? 7 plus 3 is 10, correct? Okay, then try this one. The square root of 5 times 1 minus 1 plus 3 equals 1. So that's going to be the square root of 4 plus 3 equals 1. 2 plus 3 equals 1. No. So that is not true. That means that this one, right, because of that, is extraneous. Okay. Now the last kind of problem you could get is that you could actually have more than one radical. Okay. So when you get to that first step here, which says isolate the radical, the question is, which radical? Well, you can't isolate them both at the same time, but eventually you're going to have to isolate them both. Okay. So the slightly modified instructions are isolate one of the two radicals, and then we'll undo that radical, and then we'll isolate the other one. Like in this one here, let me add the square root of x to this side. Okay, now let's undo the radical that we just isolated, right? Meaning this one right here, we're going to square it. And then when we square this, well, this one gives us the 5x plus 4. Right? This one is a FOIL, right? That's a FOIL. That's going to be the square root of x plus 4 times the square root of x plus 4. Or what's the square root of x times the square root of x? X. Right? The square root of x times 4. 4 root x. And then again, 4 times the square root of x for a total of 8 times the square root of x. And then 4 times 4 is 16. I'm glad you're all having fun, because you know what I am? Annoyed. You know what that means? You guys got to learn how to be, just settle down. Yes?
So why didn't you have when you did the square root of x plus 4 squared? Why couldn't you just like square the 4 and then just take the square root off?
What do you mean? Here?
Yeah.
Because you can't just take the exponent in on each one of those. It doesn't work that way. When you square something, that means that thing times itself. That times that. You cannot do this kind of thing. It's a common mistake, but it's very, very wrong. Right? Anytime you've got two terms, you got to FOIL it. Right? It's not like with properties of exponents. Like if I had 4x in parentheses and squared, okay, now you distribute that. You say that's 4 squared x squared because it's one term. Right? There's not a plus or a minus in between them. There would be okay. There would not be okay. Okay? So now let's see. We need to isolate the second radical, the one that we didn't already get. And I'm going to do this in a few steps here, right? Let's subtract this to this side. That'll give us 4x. Subtract 16 to this side. That'll give us minus 12 equals 8 times the square root of x. And at this point, although we say isolate the radical, if I do that, right, then I'm going to get fractions over here. And I think instead, let's just square both sides now. I mean, mathematically, there shouldn't be a problem with just having a constant in front of that. So let's go, at this step, we'll go squared, squared. Right, again, now this is a FOIL. 4x minus 12 times 4x minus 12. Right, the 4x times 4x gives us 16x squared. Right, the 4x times negative 12 is negative 48x. And you do that again, you're going to get negative 96x. And the negative 12 times negative 12 is positive 144 equals 96x. No, sorry, 64. Don't know what I was thinking there. 64x. So now that's a quadratic. So we need to subtract the 64x to the side. 16x squared, 64 minus 160. Oh, that's good. Plus 144. Okay. And because that's this 16, is it by any chance divide evenly into 160? Yes. How about 144? Yeah. So let's just divide a 16 out of everything. Right. This goes in evenly. 16 into 160 goes 10 times. And 16 into 144? 9. So this is what we're dealing with now. We have x squared minus 10x plus 9 equals 0. X minus 9 times x minus 1 equals 0. X equals 9, x equals 1. And you could check, let's see, 45, 49, that'll make 7 minus 3 equals 4. Check. Square root of 9. 3 minus 1, is that one not working? 5 times 1 is 5, plus 4 is 9. The square root of 9 is 3. 3 minus the square root of 1 would be 3 minus 1, 2. That's not good. So this is extraneous. Okay. Good. So that's what we did, and that's the homework. Let's see. These are odds.